Alright, so this is section 6.3, hard trinomials. So what we went over last time was easy trinomials, and how we identified those was there's three terms and there was nothing attached to x squared. So all we had to do is find the factors of the constant that added to the middle term, right? That was all we had to do. And when we labeled something as an easy trinomial, we could go ahead and write this first step, right? Because when we were multiplying, we were folding, we could get x squared, right? So that was good. Easy enough. Now, for hard trinomials, we have three terms, and there is something attached to x squared, and it can't be taken out. It doesn't have a greatest common factor, okay? So I'm going to teach you two ways to do this. Good news is that you're going to pick the one that you like, and you're going to use it. You don't have to figure out both ways, okay? So the first one, the least popular one, is trial and error, okay? And that's exactly what it sounds like, okay? You're going to try something, and if it doesn't work, you're going to try something else, okay? The steps here are a list of factors of the first number and the last number. You're going to trial and error it. You're going to plug it in until you add to get the middle term. So if we're looking at this problem, we can no longer do this, okay? Because we have to multiply right here and get 4x squared. So we have to list the factors of 4, which are 1 and 4, 2 and 2, and the factors of 3. We have to choose a pair of those, plug them in, multiply them, add them down, and get 7. That's why it's more difficult. So if we draw our parentheses, okay, I have to use this pair because it's the only pair, right, for 3. So I'm going to go ahead and place 1 and 3. You could have placed 3 and then 1. It doesn't matter, okay? It matters where you put all the other numbers, right? Well, if I'm thinking about this and I'm looking here and here, I'm going to notice that 4 plus 3 gives me 7. 4 plus 3 gives me 7. That's what I want. So I'm going to try and use 1 and 4, okay? If I put 4 here and 1 here, I wouldn't get it, because here's how I check. Multiply, 1x, 12x, add down, doesn't give me 7. But if I put 1x here and 4x here, and I checked it, 4x, 3x. I need a negative 7. Your sign rules are the same, okay? My signs are the same, and they're both negative. So I'm going to put a negative on both of these. If I added those down, I get negative 7. Perfect. That's exactly what I wanted. So this is my answer. Okay? You just plug it in and see if it works. If I would have said 2 and 2, I would have done 2x and 2x. Well, when I multiplied, I would have figured out that that didn't work. So I would have gone to 1 and 4. Okay? This one. List the factors of both. 1 and 6, 2 and 3. 1, my pen's acting weird. 1 and 10, 2 and 5. Okay? It's going to be pretty obvious most times when you're going to use your 1 in your number. Okay? A quick way to check is to multiply these together. 60, that's not even close. And then add them. 16 doesn't give me 19. Okay? Just like over here, I added them, right? I said, oh, 3 plus 4 is 7. Let me try that. Doesn't really happen over here for me. So I'm going to try to use 2 and 3 and 2 and 5. Pick 1 and place it there. 2x, 3x. So I said I'm going to choose these two and I'm going to put them there and say they're right. Then I'm going to try to plug these in and see if I can get them to add to it. I see that my signs are the same and they're both positive, so I can go ahead and place them. if I put 2 here and 5 here, that gives me 6 and 10, not 19, right? That would give me 16. So if I flipped them though, and I put 5 here and 2 here, and I checked, I get 15 plus 4, 19, got it. So that's my answer. All right, you're just trying them and wait until they work. This one, the only difference here is you have that y squared on the back. We worked easy trinomials like this. All you have to remember to do is tag on that y to the end of it, but you treat it the same way, right? You're going to say 1 and 8, 2 and 4, and then just 1 and 3. So I only have one pair of this number, so I know that I'm going to have a 1y and a 3y here. Okay, again, 8 and 3 give you 11. 8 minus 3, because I'm going to have different signs, gives me 5. I'm not getting 2. If I choose 4 and 3, if I put 4 here and 4 here and 2 here, that gives me 2 xy and 12 xy. That doesn't give me 2, so I know that's wrong, right? If I flip them and I put 2 and 4, I get 4xy and 6xy. I need that to add to give me a -2. So I would put the negative on the 6, right? Which would mean I would need to put it here and put my positive here, because I needed to multiply these two numbers together and get negative. So that's positive times a negative. Okay, only difference was I had this y on the back of it. Okay. All right, one more. This one looks pretty tough, right? Because you have 63, so that's a pretty big number. And then if you remember from the previous lecture in class, we talked about if you can take out the greatest common factor, take it out. So these all have a 3 in common. I can take out a 3 from every single term, so I'm going to do that. And I'm left with 2x squared plus 11x minus 21. And the pink is still a hard trinomial. So, but now my numbers are way smaller. So same thing, I'm going to keep this 3 with me, and I'm going to factor that hard trinomial. So this is 1 and 2, 21, 1 and 21, 3 and 7. I'm actually going to move this down. Write that a little better. 1 and 21, 3 and 7. All right, well, it shouldn't take you very long to figure out you're not going to use 1 and 2 and 1 and 21. You are going to use 1 and 2 because those are the only factors of 2. And then 3 and 7. So if I put 7 here and 3 here, let's see what I get. 14 and 3, and I need them to add to give me a positive 11. So positive, negative. If I add those down, I get 11x. So positive, negative. That's my answer. All right, so again, all you're doing is trying something, seeing if it works. If it doesn't, you flip them, try something else, okay? If I did that and you said, absolutely not. I do not want to do that method at all. You can do something called bottoms up. So we're going to work the same 4 problems, but we're going to work them in a different way. We're going to get the same answer. All right. This method is much more procedure-like. So you're going to do the same thing every single time. All right. So it says, that first step says multiply the first number by the last number. So what you're going to do is you're going to grab this number and you're going to take it over here to the end. Okay. So you're actually going to move it over there. So it's going to be x squared plus 7x plus 4 times 3 is 12. Well, what I did just then is I created an easy trinomial that I'm going to factor. Okay, so that's x and x. My signs are the same and they're both positive. And then the factors of 12 that add to 7 are 4 and 3. Okay, so that was step number 2. Step number 3 says divide both numbers in the parentheses by the first number. So you're going to do 2 things with that first number. At first, you're going to multiply it. Then, once you factor your easy trinomial, you're going to divide your numbers by that first number. Okay? Step number 4 says simplify your fractions. So you have 4 divided by 4, that's just 1. 3 divided by 4, well, you can't simplify that. So if you're left with the denominator, this is step number 5. If you're left with the denominator, move it in front of the x. So you're going to take this 4 and move it in front of the x. So you have x plus 1, 4x plus 3. That's the same exact answer that we got when we did trial and error, just in a different way. Okay? I want you to come up here and put a star by steps 3 and 4 because those are the steps that we forget to do. Okay? If you use this method, the mistake you'll make is you'll forget to divide those numbers. And then if you divide it, you'll forget to simplify your fractions before you write your answer. Okay? So let's do it again. First step, multiply. 6 times 10, so that's x squared plus 19x plus 60. All right, we got to think of the factors of 60 that add to 19. So 1, you have a calculator, so you would just use it. 1 and 60, my pen is acting up. 2 and 30, 3 and 20. 4 and 15, 6 and 10. Okay, obviously the one that we're going to use is 4 and 15 because those add to 19. So x plus 4, x plus 15. That's not our answer. We still have to divide by 6 and simplify our fractions down. 2 goes into both of these, so that's 2 over 3. 3 goes into both of these, so that's 5 over 2. I'm left with the denominator, so I'm going to move it to the front. So that's 3x plus 2, 2x plus 5. Okay? Same thing we got at the top of the page for that one. Okay. This one, we're going to do it the same way. Multiply x squared minus 2xy minus 24y squared. Factor the easy trinomial. Different signs. The factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We need those to add to -2, so we'll pick 4 and 6. And 6 will be negative because we want it to be a negative 2. Right, so if you need to write negative 6 plus 4 will give you a negative 2. That's how you can keep your signs straight. Divide by 8. Simplify your fractions. 4 goes into both of those, so that's a half. 2 goes into both of these, 3/4. Move them to the front. 2x plus 1y. 4x minus 3y. Same thing I got up top. Okay. And then this last one, we're still going to take out that greatest common factor like we did. Okay. But now we're just going to keep this 3 out here whenever we do bottoms up. And we're going to do bottoms up with just the purple. So we multiply the 2 to a different color. Multiply the 2. So that's x squared plus 11x minus 42. And then I need the factors of 42 that add to 11. So we have x and x, because now we have an easy trinomial, different signs. If we think about 42, you have a calculator, so you can use it. Okay, and then 14 and 3, if you subtracted those, that would give you 11, right? So 14 and 3. We're going to be careful here. I'm not dividing by 6. I'm dividing by 2. Then I'm simplifying. 14 divided by 2 is 7. 3 divided by 2, can't do anything. Move it to the front. 3 times x plus 7. 2x minus 3. Just like that. Okay? So whichever method you want to use, if you want to do trial and error, do it. If you want to do bottoms up, do it. Okay? Now you have section 6.4, so factoring special forms. Strategy 5 is the difference of two squares. So the way you'll identify these is they'll have two terms. Both terms are pretty, right? And remember, pretty means we can take the square root of them and we can get a number back, okay? So your first step is to take the square root of both terms, okay? And that's pretty much the hardest part, because one parentheses gets a plus, the other one gets a minus, and you're done. So x squared minus 36. Two terms. They're both pretty, right? I can take the square root of x squared and get x. I can take the square root of 36 and get 6. So I'm going to say, okay. The square root of x squared is x. The square root of 36 is 6. One gets a plus, one gets a minus, and that is all I got to do. Way, way, way easier than a hard trinomial, right? Okay. This one. 16 is pretty. 49 is pretty. X squared and y squared are pretty. The square root of 16x squared is 4x. The square root of 49y squared is 7y. One gets a plus, one gets a minus. Just like that. This one has two terms, but they are not pretty. I cannot take the square root of 2 and get a number, or x cubed, or 50, or x. Nothing's pretty about it. So if you come up with a strategy, but it doesn't work. So this would be considered weird, right? I don't really know what to do. I don't have a strategy. You take the greatest common factor, okay? The greatest common factor is 2x, and I'm left with x squared minus 25. The purple is the difference of two squares, right? I can say, okay, this is x and x, 5 and 5, one gets a plus, one gets a minus. Okay, so you might have to factor something out and then look inside and you have the difference of two squares. That's the same as factoring something out, looking on the inside, and you had an easy trinomial or a hard trinomial, okay? This little note says the sum of two squares does not factor. So if I had x squared plus 4, it does not factor. X squared minus 4, that's the difference of two squares, and that does factor, right? So just make sure you have a minus sign. It's the difference of two squares, okay? And then we're going to skip strategy 6 because we could always, instead of doing this strategy, we could just do easy or hard trinomial. Okay, so I'll show you this, remind me, and I'll show you this in class. But strategy 7, the sum and difference of cubes. So we have two terms, and both of our terms are going to be pretty cubes. So that's numbers like 8 and 64 and 27 and 125, okay? Pretty cubes. We can take the cubed root of that number and get a number back, okay? Your first set of parentheses is just the cubed root of both terms, okay? Kind of like we just did with our squares, right? We just took the root and we wrote them down. So that's what's going to be in your first set. Your second set of parentheses is going to follow a saying, okay? You're going to square the first, multiply together, square the last, and your signs will go same, opposite, positive. If you do not memorize this, you'll miss it. Square the first, multiply together, square the last. Memorize that. And then memorize same, opposite, positive. Okay, so here's what I mean. My first set of parentheses is just the cubed root. So x and 5, right? That's the cubed root of both terms. Now, I'm going to square the first, which is x squared. I'm going to multiply together. I'm going to say x times 5 is 5x. Then I'm going to square the last. 5 squared is 25. That was that saying. Square the first. And I'll write them down for you. I square the first. And then I multiplied together. Square the last. Okay. My signs go same. All right. Same as my problem. The opposite of whatever I just did. The last one will always be positive. So that went same, opposite, positive. Square the first, multiply together, square the last, same, opposite, positive. And that's your answer. Okay? Again, if we don't memorize that highlighted stuff, we miss it. Okay? So let's look at this one more. Two terms. They're both pretty cubes, I could have a plus or a minus for cubes, okay? It's not the same as the squares. Squares, I have to have a minus sign. Cubes, I can have either, all right? If I take the cubed root of both terms, I get 4 and 3h, right? I'm going to square the first. 4 squared is 16. I'm going to multiply together. 4 times 3h is 12h. I'm going to square the last, and we're going to be careful. I'm saying 3h, let me do a different color, 3h all squared. That means that 3 gets squared and h gets squared. So that is 9h squared. Okay? Don't make the mistake and forget to square the 3, okay? And then my signs. Same, opposite, positive. Just like that. Okay? Square the first, multiply together, square the last, same, opposite, positive. That's what you got to remember for the sum and difference of cubes. Difference of squares, all I got to do is take the take the square root of both. One gets a plus, one gets a minus. Okay?